Hello, my name is Dr. Roderick L. Rowe. And what I'm going to do today is look at a blank using the spectrophotometer. So what I want to do is take these small test tubes. This is the Genesys 30 and it can support this height. So the manual says it can support height up to 100 millimeters, 150 millimeters. This one here is only 100. So if you have these test tubes that have 3 milliliters or 5 milliliters of broth, you can use these directly into here. So what I'm gonna first do is get one of those, clean it with Kim wipe. This has just broth in it, TSB broth. This is going to be my blank. I'm going to put 3 milliliters of water in it. So I have micro pipette. I've already set it to 1,000, which would be 1 milliliter. I have some water here. I'm going to do this 3 times. They're equal height. I need at least 3 because there's a line in here. I'm gonna pull this out. It has to be at least up to here, which when I put the test tube in, it's at least up to there. So this is a cuvette holder. This is where it goes. The light passes in this direction. So I'm gonna stick this back in. Make sure it's snug. This will be my blank. I'm gonna wipe this glass of any smudges. I'm gonna stick it in. And I'm gonna calibrate the spec to this glass. I'm gonna see if I can get a little closer so you can see some of the buttons I'm going to be pushing. See if you can see. So that's the display. And I want to go to live. So I'm going to go up till I reached live display, enter. I'm going to use 600 nanometer is what is the suggested wavelength when looking at cells. So it measures the amount of light scatter due to the microbes in the solution. So that's the one we're going to use. So I already set it at 600. The number's up here. This one is the mode. You can toggle. That's absorbance. This is transmittance. C is concentration. So I go back up to the top where I put my wavelength in. That's 600. Absorbance. Then I'm going to push 0.00 to blanket. It gives me a value of 0.00. I'm going to pull this out. And now I'm going to put in broth just to see what is the difference. So I'm going to write this value down. The difference is 0.012. Let me find a pencil real quick. All right, I was able to find a pen, so I'm going to write this down. Write this down. I'm going to show you how I did it again. So I take this out. Here's my blank. It's water, deionized water. The absorbance is 0. So write it in your lab manual. Water has 0 absorbance, 0A. When I pull this out, I've already wiped broth. Broth has nothing in it, but I'm going to use broth as the media that my bacteria grows in. So I want to see the difference. So this is a tryptic soy broth. The absorbance is 0.011. Now I could just pull it out and see what my sample is. So here I have some E. coli that grew overnight, 24 hours. We want to shake it up. All the bacteria is in the bottom. You can probably see them starting to swirl around. Now they are suspended. I'm going to take some out of here and put it into the broth. So the first one I'll do is I'll take out 100 microliters. I'm going to use a different pipette, 20 to 200 microliters. I've already adjusted this to 100. I'm going to use a different type of tip. I got my new tip. I'm going to label this sample, so S 100. No, yeah, we'll do 100. So S 100 means I'm going to put 100 microliters of my E. coli into this 3 milliliters. Then I'm going to measure it to see what the concentration is. Since I'm going to use bacteria, I want to turn my flame on to try to keep an aseptic environment. Make sure it's really agitated good. Pop my cap. Suck it up and down a couple times. Come out. All right, I put 100 into that one. I'm gonna go ahead and set them all up. I'm gonna grab another one, label it sample, and I'm gonna put 500 in that one. And the last one is sample, and I'm gonna put 1,000 into that one. So I've already put 100 now. This is my normalized control, doesn't have anything in it. This one has 100, this will have 500, and that will have 1,000. So I will need a different pipette. This one only goes up to 200. I will use this one that goes up to 1,000. So let me adjust this to 500. Agitate. Suck it up and down. Suck it up and down, mix it real good. So this one has 500 microliters, or half a mil. I'm gonna go back into my original and take out 1,000 now. Let me adjust this to 1,000. Suck it up and down. I pulled out 1 milliliter, or 1,000 microliters. Suck this up and down. So as you can see, the concentration of bacteria went up. So this needs to be discarded. This is a dirty tip, so I'm gonna put it into a waste bin. The waste bins should be at your table. This one broke. Some student might have messed that one up. Now that I have them all prepared, now I'm going to measure the absorbance. I already have it set. I'm going to normalize it back to water. It's off a little bit, so I'm going to re-blanket. It's 0.00. I'm going to pull it out. I'm going to put the first one in there. The first one had only 100 microliters of bacterial culture. So this one, the absorbance reads 0.069. Pull that out. The next one has 500 microliters in it. It reads absorbance 0.240. Pull that one out. The last one has 100. Wipe it. This one reads 0.414. So as you see, as I increase the concentration of stock into here, the number went up. Now this is an overnight culture, and I have at least 9 milliliters in there. So I need 3 milliliters. I'm going to take a blank slide, and I'm going to put 24 hour. So 24 hours of agitation with E. coli gave me this. I want to know what that turbidity is, how cloudy that is. So what I'm going to do is get at least 3 milliliters, because that's how much I need of the original stock. I'm not going to dilute it at all. Let's see what that is. One, 2, 3. So that has 3. I'm going to make sure I blank this again using my sterile water. Make sure it's zeroed out. It's close, 0.001. It's been blanked. Pull the water out. Put my 24-hour culture in there. So that is too high, but I'm gonna give you the number. So the 24-hour culture reads 1.129. So that is the absorbance. That would be too concentrated for you to run your experiment. You would have to dilute it. Now I'm going to figure out the right dilution to give us the best results. I performed this in the past, and I believe I have it written down. Let me find it. Yeah, I don't have it here, so what the actual absorbance is, but that's what we're going to figure out, and that'll be on a subsequent video.